So now let's talk about how to make a complex conjugate. So given a complex number, for example in this form we have z equals to x plus iy, you can find the conjugate of it and represent it in different ways. So one way is to represent the complex conjugate by the bar on top of the letters that represent the complex number, or you can put a star at the top of here to show that this is a conjugate. So how do you make a conjugate operation? So when you take a complex conjugate, you are going to write something like this: x plus iy and a bar. So the bar above this x plus iy, it is to show that this you are going to be taking the conjugate of this number. So when you take the conjugate of this number, the real part doesn't change because the real is still the same. So you're going to have x, but the imaginary part is going to change sign, so that when you start with a positive sign, then this you will end up with a negative iy. On the other hand, if let's say you start with z equals to, let's say this is z2, this is x minus iy, now your complex conjugate is going to be equals to x minus iy conjugate, and this is going to give you, you just have to change the sign so that this is becoming x plus iy. Okay, so that is how you make a conjugate operation. Now let's take it, for example, a case where my z is equals to minus 1 minus I. The same example that we have talked about before, and we are going to look what is the effect of doing a conjugate operation. So now when you plot it on the Argand diagram, you will have this is x, this is 1, and let's call this as negative 1, and over here is 1, and this is 1, over here this is negative 1. So when you want to plot the z equals to minus 1 minus I, you are going to have a line that is on this part of the quadrant where this is negative 1, x equals to negative 1, and y is going to be negative 1. So I have a point over here. So this is going to be a line. So this is my z. Now if you take the conjugate of this, so now if you, let's say you take the conjugate of this, this is going to give you negative 1 plus I. So over here you have negative 1 plus 1, because now your y is equals to 1. Right. So now this is set bar. Okay. So over here you will see that when you change the when you take the conjugate of it, the angle is going to change because the angle is defined from here, and this is different from here to here. So in the previous example, we talked about if you find the angle over here, the angle is going to be equals to 5 pi over 4. Okay, and you can get this by looking at the relation of y equals to r sine theta, that theta is equals to arc sine of y over r. Okay, and here you will get this as equals to negative 45 degrees. So now if you look at this is going to give you, if you look at the angle, this is going to be arc sine of y over r again, but now your y is going to be equals to 1. So now instead of minus 1, you're going to get you're going to find arc sine of 1 over square root of 2, and this you will get 45 degrees. So here it means the angle that is made between this over here with this line with the x-axis is going to be 45 degrees, and the angle now, if you define from here, is going to be 135 degrees. Okay, so this is going to be equivalent to writing 3 pi over 4. So now if you write this in the form of r e I theta, this is going to be square root of 2 e I 3 pi over 4, or the same as writing square root of 2 3 pi over 4, whilst the z equals to minus 1 minus I, this is of the form square root 2 ei 5 pi over 4, or square root of 2 5 pi over 4 here. Right. So here you see, when you take the complex conjugate, you are just going to change the angle of this line. Okay. Right. So basically that is how you do a complex conjugate and what is the effect on the plot. And now what you need to know is to familiarize yourself with how to change a complex number from one form to another, and you should be able to plot it in the correct manner.